Today we're going to be talking about lines, functions, and graphs. And there are three major forms of equations of lines I want you guys to know. Slope, intercept form you should know. Y equals mx plus b. And you can always use this form of a line, but the one I'm going to be using most often is point slope, which is y minus y1 equals m times x minus x1, where m, remember, is our slope, and a point that's on our line, and this is any point, x1, y1. And now general form of an equation of a line, ax plus by equals c. And in order to graph the general form, you'd have to put it into slope-intercept form. Okay, our first example is to write the equation of a line through P that is parallel to the line and perpendicular to the line through the point. So I need to solve this bottom equation, which is in general form, for y. So I can figure out what my slope is. So I subtract 6 and add 3y to both sides. Now solving for y, I get 4/3 x minus 2. Now to write the equation of our line, I'm going to be using point slope. Since that's the one I'm going to be using all year, I want you guys to get familiar with it. Okay, so for our parallel line, parallel lines have the same slope. Remember, this point is going to be our x1 and y1. So I have y minus 3 is equal to our slope, which is 4/3 x minus a negative 12. Now for our perpendicular line, remember our slope is going to be the opposite reciprocal. So we have the same point, y minus 3 is equal to, now our slope is the opposite reciprocal, 3/4 x plus 12. Okay, domain restrictions. There's really two types of functions that have domain restrictions. Rational functions. So a rational function is when we have a function on top over another function. And really the domain restriction there is the bottom function cannot equal 0 because we can't divide by 0. Now for radical functions, when we have a radical function, that's some certain root of some function underneath a radical sign. Now there's really two cases. There is the case if n is an odd number. And the most common one that you guys are familiar with is the cube root of x. Think about the domain and even range for that is all real numbers, because I can take the cube root of a positive, a negative, and 0. Now if n is even, like y equals the square root of x, your x's have to be positive, or x has to be greater than or equal to 0. Okay, closed intervals, open intervals. So remember, open intervals, not including the point, is if I have parentheses. So wherever I have parentheses. Closed intervals, inclusive, is where we have brackets. Okay, just a quick review of open and closed intervals, because that's how we're going to be writing our domain and range and a lot of interval notation throughout this year. Okay, identify the domain and range, then we're going to graph it on our calculator. So, I've identifying the domain and range. This function under here has to be positive since we're talking about a radical function. Now think about when that function has to be greater than 0. There's a few ways to do this. The way that you guys are most familiar with is solving essentially that quadratic, getting the zeros for that. Or our critical points. So our two critical points are positive and negative 4, so we put those on a number line. And then we test a number. We test a number less than negative 4. When I test a number that's less than negative 4, say negative 5, in this inequality, we get negative 9, because we have 16 minus a positive 25. That's a negative 9. That means that this is false. Or basically, when I plug in the number into this function, into our original function, I can't have that number in my domain because we can't take the square root of a negative number. Say now when I plug in 0, here, when I plug in 0 into this inequality, we get 16 is greater than 0. That's true. So anything on this interval here is going to be part of our domain. And then say I plug in positive 5, again, same thing, and this is false. So our domain for our function is going to be from negative 4 to 4. Now the range. The range is a little bit more complicated. Look at what this function looks like. Or even look underneath. Underneath, that's a parabola, with that vertex being 0, 16, since it opens down because of the negative and we're shifted 16 units up. Well, now if I square root all of these x values, if I square root everything, my outputs are going to be essentially the square root of each one of those numbers. So my range, the highest it could be, is 4. Or if I plugged in 0 here for x, if I plugged in 0, basically I'd have the square root of 16, which is the highest number it could be. Now if I plugged in negative 4 and 4, our output would be 0. We also know this is 0 because the y's can't be negative. When you square root, you can't get a negative number out. Okay, and our graph looks like that. Now, the graph is a little deceiving on our calculator because the amount of pixels on the screen. The graph should look like a half of a circle, just so that you guys know. And this is going to become very important to us second semester. Okay, even and odd functions. Please make sure you write this down. Even and odd functions have important similarity properties. This right here in this yellow box is the definition. That's how you're going to show me that a function is even or odd. It's even if this property is true. If I plug in negative x and get out the same function. A function is odd if we plug in a negative x and I get the same function as if I were to multiply the whole function by a negative. And this is how you're going to show me again whether a function is even or odd. Now, a graph is even if it's symmetric about the y-axis. So that's one of our properties. And a graph is odd if we're symmetric across the origin. Odd is origin. Or basically, negative x and negative y. So if I plug in a negative x and a negative y and I get the same function back, we're going to be symmetric, which is really what this is. Negative x function equals the negative y function. Okay, determine whether this function is even, odd, or neither. So I'm going to first test even. So I find the f of the negative of x. So I plug in negative x wherever I see an x, which equals negative x cubed plus x, which is the same thing as negative x cubed minus x. Now, this is f of negative x. Is it even? No. Because, and I'm going to be big on writing this year, because f of negative x does not equal the original function f of x, because I don't get this same function back. Now odd. What was f of negative x? Well, we just did that work. That is negative x cubed minus x, which again is the same thing as negative x cubed plus x. Negative f of x is equal to negative of our function, which equals negative x cubed plus x. So we are odd because f of negative x equals negative f of x. And I would want you guys to use these definitions and explain to me why. Okay, graphing a piecewise function. To throw this in, this should be fairly quick for us. You guys have been doing these a lot. Graphing that top function, it has a domain restriction. So it's the line y equals 2x minus 1, but just for negative x's. So I have a closed hole at negative 1 and a negative slope. So I'm graphing my slope of my line. And that's what our line looks like. Now the other function is a parabola shifted up 3. And that's for the x is greater than 0. So at positive 3, I'm going to have an open hole. Then plug in 1. You should get 4. Plug in 2. You should get 7. So that's what that graph looks like. Okay. Composite functions. Really what I want you guys to write is composite functions are f of g of x or a fog function. Some math teachers are going to talk about that as a fog function. Okay, write as f of g of x. So here we're finding the composite of g of f of x. So g of f of x. F of x is 2x plus 3. And that equals, okay, g of x is x squared minus 5x. But what is x? X is this whole piece inside here. So this is 2x plus 3 and 5 of 2x minus 3. Now we just need to simplify. So I have 4x squared plus 12x plus 9 so we get 4x squared plus 2x minus 4. Okay, our next example, we begin with a circular piece of paper that has a 14-inch radius as shown, and we cut out a little sector and we fold this up and we make it into a cone. Express the circumference of the base of the cone. So circumference, remember, is 2 pi r. So the whole circumference of this circular piece of paper would be 28 pi, but we cut out some x portion of it. Okay, so express the radius r. R is down here, the radius of our base of our cone. So when you think about it, the radius of the base of this cone, this circumference here, this came around and this formed this piece of our cone. So express the radius r as a function of x, where the circumference of our cone, or the radius of the cone, would equal the circumference divided by 2 pi. Then I substitute in what we got for c in part 1 to be 28 pi minus x all over 2 pi, which that simplifies to be 14 minus x over 2 pi. Part C of this example. Now we need to express the height as a function of x. Well, we have a right triangle in there. So h squared plus r squared is going to equal 14 squared. Solving for h, we get the square root of 196 minus r squared. Now we just chose the positive version of our square root because height is always positive. Now h needs to be a function of x, so I need to get rid of this r squared. Well, we just found an expression for r. So r squared, r we said was 14 minus x over 2 pi. So then from here, we're going to simplify. And I want you guys right now to take a minute, stop the video, and simplify. I'm not going to go through the simplification steps for you guys. So right now, stop the video and simplify. Hopefully you just stopped the video and simplified. And when you simplified, when you went through and simplified everything here, you should have gotten on the top the square root of 56 pi x minus x squared all over 2 pi. So now we need to express the volume as a function of x. Volume is 1/3 pi r squared h. So now simplifying that, we need to get rid of the r and the h. Well, we have expressions for those. R squared for r squared, we have the function of 28 pi minus x all over 2 pi squared. Now for h. For h, we have this function that we have over here. 56 pi x minus x squared, the square root of that, all over 2 pi. Now simplifying that out a little bit. Distribute the squared to this top piece, but don't multiply it through. Don't FOIL that out. Leave the square root intact also. On the bottom, now what would the bottom simplify to? Here I would have 4 pi times another 2 pi times a 3. On the bottom, that simplifies to 24 pi squared. I would have had pi cubed, but one of my pi's canceled with the pi up top. So this is our formula for volume. This is super important because we're going to be writing a lot of functions later on in the year.